Okay, Sean is saving up money by washing cars this summer. He already has $60. He charges $10 per car. Write an equation representing his earning. So we're going to identify the variables first of all. There's two ways you could do this. We could use function notation. And the function notation, we could do this. We could say that the dependent variable is his savings as it relates to the number of cars he washes. And we could say that that is the dependent variable. Or we could just call it y. Either one. This is the savings variable. Savings. And that's a dollar amount. Okay. The other is the actual number of cars that he washes. Okay. So we can call that C for number of cars. Or if you want to be more generic, you can just say X. But in both cases, these mean number of cars washed. Okay, so that's identifying the variables. So you know what the equation is talking about. Again, this is the input right here. This is the independent variable. This is our output. This is the result of washing the car. We get money for it. Okay, this is the number of cars, and this is dollar amount. Okay, so if we write this in function notation, we would say that the savings as it relates to the number of cars washed is, now we're looking for a rate. So I'm thinking we're going to be following the format of y equals mx plus b. And m is going to be our slope, and it's also the rate. Well, what in this problem is a rate? Well, right here, we see $10 per car. So for every car he washes, he gets $10. So my guess is that is going to be our slope. That's going to be the m. So we would write, following this form, we would go 10. Now if we write it in this notation, it's going to be 10c. And then he already has $60 in his account, so that's already there before we even start washing cars. And that's going to be our B. That's going to be the beginning amount. So that's going to be, we're not going to start at 0, we're going to be up here someplace, okay? So in function notation, this would be the equation representing his savings. Now, if I wrote this in just x and y, it would look like this. Y equals 10x plus 60. Looks really the same, but it's just a difference between function notation and regular xy notation. Okay. Now, when I'm doing my graph, it says here, graph is projected savings, including title, labels, and scale. Remember, you can scale the graph differently than once. Well, I know that this, for every car, you're going to go up $10. And so I'm thinking, and we're going to start at 60. He's starting at 60 for the 0 month at the very beginning. So if we go every month, I don't think that's bad. So 1 month, 2 months, 3 months, 4 months. So this would represent the 5th month, 6, 7, 8, 9. Here's our 10th month, 11th, 12th, 13th, 14th, 15th month. And over here, you would count all the way out to 19 months. Okay. And I think if we go by $10 increments, that's not bad. So 10, 20, 30, 40, 50, 60, 70. Whoops, let's back that up. I don't think that was right. So 60, 70. So this would be 80, 90, 90. This would be 100, 110, 120, 130, 140, 150, 160, 170, 180. And that's probably pretty good. So his first, so at the very beginning on 0 months, he already has $60 in the bank. So we would put at 0, we would put our first point at 60. Okay. And every car, now these don't represent months. These represent number of cars. So this is the number of cars washed. Number of cars washed. Okay. This represents dollar amount in our savings account. Okay. So he starts off with 0 cars washed, $60 in savings. He washes a car, he makes $10. He washes 2 cars, he makes another $10. So every car he washes, he increases by $10. So, and the fact is that he's washing individual cars. It is not a continuous graph. It's going to be what we call a discrete graph. Discrete. Graph. Because the points are separate, distinct, and it's separate and distinct and countable. So this would be the correct graph. It wouldn't be it wouldn't be a solid line. It would be dotted. Each point representing a car being washed and that much more money being put into savings. Okay. So that's number 9. Number 10. Okay, here, if you're planning to join a gym, you're comparing the prices of 2 local gyms. Okay. So Gold's Gym, the cost as it relates to number of months is 25M plus 50. So the 50 represents the beginning fee, right? And the 25 is the monthly cost. It's the rate, $25 a month. So that's why you get 25 times the number of months plus 50. That's Gold's Gym. Now, we need to come up with Jim's Gym, what that equation would be. So we're going to call this C parentheses M parentheses G. I'm going to put a little G there. And we're going to name this equation C parentheses M parentheses J for Jim's Gym. Okay. Now, if you look at the increases, so for every month of every additional month, you go up by $10. Another month, this is a positive 1. That's a positive 1. You go up by positive 10. So my slope, my M, if we're doing this mx plus b, my slope here is going to be 10 over 1, which is 10. So it's going to be 10m, but we need to find out this number. Now, this number 50 is the original membership fee before any month. So if I were to do this right here, this would be like if I wrote 0.50. Well, excuse me, if I did that, sorry about that, messed up. Let's try that again. What I meant to say was if I did that for Gold's Gym, if I had a table there and I had number of months and I had cost, his would have been 0 and 50 for Gold's Gym. What would have been for Jim's Gym? Well, if it's constant, if I go down a month, so let's say this was a 1 month change. So this was 0, went from 1 to 0. Well, if I'm going from 100 to 90, another $10 down would have been 80. So at the very beginning, I would have paid 80 bucks. So that would have been my fee. So my equation there would have been 80. So my equation then is going to be the cost as it relates to months for Jim's Gym is equal to 10 times the number of months plus $80. Now, after how many months will the cost be the same? Well, so what we're asking is, when is the cost for Gold's Gym equal to the cost of Jim's Gym? When will that be the same? So let's set the two equations equal to each other. So we're going to go 25m plus 50 equals 10m plus 80. So let's get the m's on the left side, the variables on the left side of the equation. So let's subtract 10m from both sides of the equation. $15m plus 50 equals 80. Okay, let's carry on here. And now let's carry that over. So I got 15m plus 50 equals 80. Now let's subtract, let's get rid of the 50 on the left. So we're going to subtract 50 from both sides of the equation. So I get 15m, so these are gone. And I go 15m equals 30. And then I divide both sides of the equation by 15. And I wind up with m equals 2. So at the end of the second month, at end of second month, cost will be equal. And finally, which gym would you join if you plan on going for 6 months? Well, if it's less than 6 months, I would probably go with Gold's Gym, because the membership fee, the startup fee, is cheaper, right? So at the very beginning, Gold's Gym would be less expensive. But anytime after 2 months, Jim's Gym would be the least amount. So at 6 months, let's just plug it in real quick. So here, at 6 months, Gold's Gym, the cost at 6 months is going to be 25 times 6 plus 25 times 6 plus 50, which gives you 150 plus 50, which is $200. Jim's Gym, on the other hand, that cost at 6 months is going to be 10 times 6 plus 80, which is going to be 60 plus 80, which is going to be 140. So in 6 months, at 6 months, Jim's gym is $60 cheaper.